Okay, para sa harmonic sequence, it is formed when you take the reciprocals. Okay? So, meron tayong keyword na ginamit dito, reciprocals, of each term involved in an arithmetic sequence. That is, if a sub 1 is your first term under arithmetic sequence, we have this expression, h sub n equal 1 over a sub 1, 1 over a sub 1 plus d, 1 over a sub 1 plus 2d, until you reach 1 over a sub 1 plus quantity n minus 1 times d. Ito lang naman yung harmonic sequence. Kapag meron kang nakaset na arithmetic sequence at kinuha mo yung reciprocal ng bawat term, makukuha mo na yung ating sequence na hinahanap, which is si harmonic. Let us give an example. Yan. Example. If the first 5 terms of arithmetic sequence is 5, 2, negative 1, negative 4, and negative 7, find its harmonic sequence. Find its harmonic sequence. Yan. For the solution, ang kailangan mo lang gawin is kunin yung reciprocal ng bawat term. Alam natin na ang a sub 1 ay 5. Okay? Now, yung reciprocal nito, which is h sub 1, is 1 over 5. Okay? Next, we have a sub 2. And that is 2. Get its reciprocal. We have h sub 2 equals 1 half. Okay. A sub 3. Ang a sub 3 natin is negative 1. So, get its reciprocal. Makakuha natin si h sub 3. And that is still negative 1. A sub 4 is negative 4. Get its reciprocal. You have h sub 4, which is negative 1 over 4. And lastly, we have a sub 5, that is negative 7. Reciprocal, we have h sub 5, and that is negative 1 over 7. Okay. Kung mapapansin natin, class, na yung ating nakuwang terms, 1/5, 1/2, negative 1, negative 1/4, negative 1 over 7, is pwede natin i-list. No? So, meron tayong 1/5, 1/2, negative 1, negative 1/4, and ang huli ay ang negative 1 over 7. So, ito yung ating desired harmonic sequence. Find the ninth term of the harmonic sequence 2, 8 over 7, 4 over 5, 8 over 13. Kung titignan natin, no, mas maganda kung i-convert muna natin siya into arithmetic sequence since meron tayong formula doon, no, to obtain the nth term or specifically yung ninth term. Now, paano siya i-convert into arithmetic sequence? Just get the reciprocal of each term, no? Yung 1/2, no? So, as a solution, okay, solution. Okay. First, convert the given sequence into arithmetic sequence, no? That is 1/2, 7 over 8, 5 over 4, 13 over 8, and so on. Now, get its common difference. So, let's say we have 7 over 8. So, that is D. 7 over 8 minus 1/2. And that is equal to 3 over 8. Right? Pwede rin natin kunin yung 5 over 4. subtract natin yan, no? Or subtract natin yung 7/8 sa 5/4, makakakuha pa din tayo ng 3/8. Or kung gusto natin ipagpatuloy pa, halimbawa si 13/8, subtract naman natin sa 5/4, still 3/8 pa din yung ating makukuha. So, ang common difference is 3/8. Right? Now, to get the ninth term, okay, so we have a sub n equals a sub 1 plus quantity n minus 1d. Okay. A sub 9, no? A sub 9 equal a sub 1 given tayo, that is 1/2. That's 1/2. Hindi ito guys hindi ito kasi ito ay harmonic. Ito yung kukunin natin dahil ito yung naka-arithmetic sequence. So, that is 1/2 plus, since 9 ang ating kinukuha, n is equal to 9. So, 9 minus 1 is 8. Then, d, and d is 3/8. So, that's 3/8. As you can see, makaka-cancel yung ating 8 dito. At meron na lang tayong matitirang 3. Kaya, ito ay pwedeng isulat as 1/2 plus 3. And that is your a sub 9. 1/2 plus 3 is 7/2, no? That is 7/2. Kaya lang, hindi yan yung hanap natin. What we are looking for is the harmonic sequence, the ninth term of the harmonic sequence. Para makuha siya, all you have to do is to get its reciprocal, 7/2. So, therefore, your h sub 9 is 2/7. Ito yung ating hinahanap na kasagutan. Now, consider the following sequence. Let's say we have 2, 4, 8, 16, 32, and so on. Do you see a pattern? Yes, we have a pattern here. Each term na nakukuha natin is nagmumultiply tayo ng 2 from our first term or sa initial term. So that is 2 times 2, we have 4, times 2, we have 8, times 2, 16, and times 2, we have 32, and so on and so forth. Okay. Now, yung minumultiply natin na 2, yun yung pattern dito sa sequence na to. And observe, once na kinuha natin yung quotient nung succeeding term doon sa previous term, okay, 4 divided by 2 is 2. We have 8 divided by 4 is also 2. 16 divided by 8, 2. 32/16 is 2. Okay. Mapapansin natin na pare-parehas ang lahat ng mga ito. So, yun yung common po sa bawat terms na meron tayo. At tatawagin natin siyang common ratio since, yun nga, common po. And at the same time, we are performing division. Kaya nagkakaroon tayo ng fraction or ratio. That's why common ratio yung ating term. Now, let us denote G sub n be the position of each term in this sequence. Okay, so that we have G sub 1 and that is 2. Okay, that's 2. G sub 2 ay makukuha natin kapag nagmultiply tayo ng 2 sa first term. So, that is 2 times 2. Right? So, meron tayo dito 4. Next, yung G sub 3 ay makukuha kapag nagmultiply tayo ng 2 twice sa ating first term na si 2. So, G sub 3 is 2 times 2 times 2. And we have 8. G sub 4 3 times naman tayo mag-multiply ng 2 sa first term. And we have 2 times 2 times 2 times 2. So, ito yun. 3 times, 2 times, 1 time. Okay. Next, we have g sub 5. At this time, we have to multiply 4 times to obtain 32. Here in g sub 4, we have 16. Okay. Now, kung palalakihin natin yung subscript, let's say 100, so we have g sub 100, hindi natin kayang ilista ito ng manual, no? Or mano-mano. So, 2 times 2 times 2 times 2 times 2 up to 100. That's why we are trying to make some notation or yung tinatawag nating exponents, no? Para mas maging simple yung ating expressions. Now, kung mapapansin natin, yung g sub 5 ay pwede natin siyang isulat as 2 times 2 raised to 4. G sub 4 is 2 times 2 raised to 3. G sub 3 is 2 times 2 raised to 2. For G sub 2, we have 2 times 2 raised to 1. And for G sub 1, we have 2 times 2 raised to 0. Ay. Now, yung pattern na meron tayo sa ating sequences, G sub 1, if the subscript is 1, the exponent is 0. G sub 2, 1 ang exponent. Para naman sa subscript na 3, nagbawas ka ng isa at magkakaroon ka ng exponent na 2. Para sa G sub 4, bawas ka isa, we have 3. G sub 5, bawas ka ng isa, we have 4. So, yung napansin nating pattern na meron tayo ngayon dito is nagbabawas ka lang din ng isa, just like sa ating arithmetic sequence. Pero, here, nasa exponent yung ating binabawas. Right? Now, we can create or generate the general form. We have g sub n is equal to 2 times 2 times 2 times 2 times dot 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 times hanggang sa nth term. Okay. We can write this as 2 times gawin natin color blue. We can write this as 2 times 2 raised to n minus 1. So, bawas ka lang ng isa. No? Here, kung mapapansin natin, right, so, naka-equate yan sa g sub n. So, g sub n now, ay pwede natin siyang i-generalize. So, 2 is our first term. So, that is your g sub 1 times 2 is the common ratio na nakukuha natin kanina. Yun yung common sa bawat 2 terms na meron tayo, 2 consecutive terms. I-denote natin siya as R. Then, as is yung exponent na n minus 1. This is your formula for another sequence na tinatawag nating geometric sequence. Right? Where G sub n is your nth term of geometric sequence. G sub 1 is the first term. R is the common ratio. And N is the number of terms. Number of terms. Now we can define our geometric sequence as, paano natin siya i-define? Okay. So as a definition, it is a sequence, a geometric sequence is a sequence in which each term after the first is obtained by multiplying the preceding term by a fixed number. And that fixed number is called the common ratio. Common ratio. And we have the general formula as G sub n equal G sub 1 times R raised to n minus 1. There you have it. Example, find the seventh term of the geometric sequence whose first term is 5 and R or the common ratio is 4. As a solution, okay, kunin muna natin yung given at yung mga unknown. Okay. Seventh term, yan po ang hinahanap. That's why G sub 7 is question mark. If G sub 7 is our concern, we can say na ang n is equal to 7. Okay. First term is also given. So, G sub 1 is equal to 5. And R is equal to 4. Okay. By geometric sequence formula, we have G sub n equal G sub 1 times R raised to n minus 1. All we have to do is to substitute the given values. So, we have G sub 7 equal G sub 1, which is 5, times 4, since R is equal to 4, and n minus 1, so we have 7 minus 1, that is 6. Simplify, G sub 7 is equal to 5 times 4 raised to 6, which is 4,096. Then, get the product. 5 times 4,096 is 20,480. Okay. Ang goal lang naman ng geometric sequence is to obtain the terms, no, na may malalaking positions, no. Let's say G sub 100, G sub 500, and so on and so forth. No, you can find the desired answer instantly, no, with the help of this formula. Malaking bagay ito. Okay. Pero kung kaya mo naman kumpitin ng mano-mano yung nth term, wala namang kaso, no? Pwede mo namang gamitin yung sarili mong paraan compared or versus dito sa ating geometric sequence formula. Okay. For our second example under geometric sequence, find the first term and the common ratio of a geometric sequence whose fourth term is 2 and its seventh term is 1 over 32. As usual, ilista mo lang muna yung mga given para hindi tayo malito. So, ano ba ang given? Fourth term, that is 2. If that is the term we are looking for, kaya yung n natin ay mapopersa maging 4. Okay? Next, G sub 7 is 1 over 32. Kaya ang n natin ay magiging 7. Okay? Ang hinahanap ay ang first term, that's why it is a question mark, and common ratio as well. Okay. Now, meron tayong dalawang cases. Para tong yung last example under arithmetic sequence, no? Magkakaroon tayo ng dalawang equation. So, ganun din yung gagawin natin dito. Okay. By geometric sequence formula, and that is G sub n equal G sub 1 times R raised to n minus 1. Okay. So, gamitin natin yung fourth term, no? Using fourth term, okay, we have 2 or tama 2 since ang fourth term ay 2 equals G sub 1, unknown yan, times R, still unknown, raised to n minus 1. Since nasa loob tayo ng G sub 4, papaganahin natin yung n as equal to 4. So, meron tayong 4 minus 1 which is equal to 3. tawagin natin itong equation 1 since gagamitin natin siya later. Okay. Using 7th term, okay, we have now 1 over 32 equal g sub 1 times r raised to 7 minus 1, which is equal to 6. And dito, tatawagin naman natin itong equation 2. Right? Or mamaya natin tawaging equation yan. Kasi pwede pa itong ma-simplify, no? No? Ito, pwede itong gawing divide ka r cube both sides, makakakuha ka ng 2r cube equals g sub 1. Right? And ganun din dito. If you try to divide r raised to 6 both sides, makakakuha ka ng 1 over 32 r raised to 6 equals g sub 1. So, tawagin na natin ito ngayong equation 1 and equation 2. Okay. From equation 1 and 2, okay, from equation 1 and 2, notice g sub 1, no, has a value of 2 over r cube for equation 1 and 1 over 32 r raised to 6 for equation 2. No? So, g sub 1 is equal to g sub 1. Pwede natin siyang ipag-equate, right? Since parehas lang naman yan. E saan ba equal yung g sub 1? We have 2 over r cube equal 1 over 32 r raised to 6. Bakit natin ginawa to? Para makuha natin yung value ni r. No? So, we're going to proceed with this process, no? Para makuha natin yung common ratio. How? All you have to do is to conduct a cross multiplication. So, makakakuha tayo ngayon ng 2 times 32r raised to 6 is 64r raised to 6 equal 1 times r cube is r cube. Divide r cube both sides. Cancel. Right? R raised to 6 over r raised to 3 is r cube. So, you have 64r cube equals 1. Okay? Then, divide 64 both sides to cancel this numeric value sa left side. So, you have now r cube equals 1 over 64. Now, to get the value of common ratio, all we have to do is the final process is to cube root. To get the cube root of both sides, okay, cube root of r cube will turn into r. Now, by algebra, we all know that, let's say we have an index n, square root of x over y. This is equivalent to nth root of x over nth root of y. Okay. Nth root of x over y pala yun. No? Now, this is equal to cube root of 1 over cube root of 64. Cube root of 1, alam natin na ito ay 1. Cube root of 64, that is 4. Hence, the value of r, r is equal to 1/4. Aanhin natin yung r is equal to 1/4. We can substitute that either in equation 1 or equation 2 to obtain g sub 1. Okay. Substitute natin yung 1/4 sa r, either kay 1 or kay 2. Mas madali kapag sa 1, equation 1, since may 32 tayo dito, mapapalaki yung value natin. Pero okay lang naman din kung gusto nyo sa equation 2. Same lang naman na magiging result. Now, let's say, i-substitute natin to by substituting r equals to 1/4. on equation 1, okay, we have, ano ba yung equation 1 natin? 2 over r cube equals g sub 1. No? So, we have g sub 1 equal 2 over r cube, which is 1 over 4 cube. And this is equal to what? 2 over 1 over 64. Simplify, we will obtain 128. Therefore, g sub 1 and r is 128 and 1/4 respectively. And we are done. Alright, let's move forward for our last sequence that we have, which is Fibonacci Sequence. Ano bang meron dito sa sequence na to? To formally define this sequence, we start by defining f sub 1 equals 1. Okay? F meaning Fibonacci. Start with letter F. F sub 2 is also equal to 1. Okay? Now, since sinabi natin under the definition of sequence, the domain should be strictly positive integers, no? Pwede tayo mag-start sa 1. That is the minimum. 1, 2, 3, and so on. That is the value of n na pwede natin i-insert. Okay? Since nagamit na natin yung 1 and 2, kailangan ang minimum value of n natin is greater than 2, which is 3. And we will define this sequence as f sub n equal f sub n minus 1 plus f sub n minus 2. Let n is equal to 3. Okay? So, if n is 3, we have f sub 3 equal f sub 3 minus 1 by this plus f sub 3 minus 2. And we have f sub 3 equals f sub 2 plus f sub 1. Ang sabi natin, ang f sub 2 at f sub 1 ay 1. They are 1. So, we have 1 plus 1. 1 plus 1, which is equal to 2. Hence, f sub 3 is equal to 2. Now, what if the value of n now is 4? So, we have f sub 4 equals f sub f sub 4 minus 1 plus f sub 4 minus 2. Okay? Now, f sub 4 is equal to f sub 3 plus f sub 2. Since f sub 3 is equal to 2, pwede natin i-substitute ito ng 2. And yung f sub 2, naka-define siya as 1. So, substitute as 1. Hence, the value of f sub 4 now is equal to 3. And meron na tayong sequence na nabubuo. We have 1, 1, f sub 1 and f sub 2. F sub 3 is 2. F sub 3 or f sub 4 is 3. And so on and so forth. Observe na makukuha mo yung succeeding term kapag nag-add ka ng last two terms na meron tayo sa sequence na to. 1 plus 1 is 2. 1 plus 2 is 3. 2 plus 3 is 5. 3 plus 5 is 8. 5 plus 8 is 13. And so on and so forth. Ganyan gumagana ang ating Fibonacci sequence. So at its formal definition, Fibonacci sequence is the series of numbers 1, 1, 2, 3, 5, 8, 13, 21, 34, and so on and so forth. Some books, ang first element under this sequence is 0. Nilalagyan nila ng 0 dito. And yung 0 is defined as f sub 0. So wala namang kaso dun kahit na 0 yung gamitin as our first term. Okay lang yun. As long as ang label niya is f sub 0. The next number is found by adding up the two numbers before it. The 2 is found by adding the two numbers before it, 1 plus 1. The 3 is found by adding the two numbers before it, 1 plus 2, and so on. Gaya ng sinabi ko kanina. Now, isa sa mga applications ng Fibonacci sequence is naturally natin nakikita. Okay. Minsan, hindi lang natin nare-realize na meron na palang Fibonacci sa part na yon. Halimbawa, sa breed ng mga rabbits. Mag-start tayo sa number of month and number of pairs. No? Ang kwento natin ay nagsimula sa 0 month. Meron tayong dalawang baby rabbits. Okay? These are baby rabbits. Pares po sila. Okay? Isang babae, isang lalaki. Now, number of pairs that we have is 1. After 1 month, yung baby rabbits natin ay naging adult. Yung adult rabbits natin is i-labeled natin as color blue and yellow. So, sila pa rin po yun. Walang nadagdag. So, the number of pairs is still 1. How about for the next term or next month? After another month, yung ating adult rabbits, still, sila pa din. Then, sila naman po ay nanganak ng baby rabbits. And for this month, meron tayong dalawang pares. Isa, dalawa. After another month, which is yung third month po natin, yung adult rabbits, yung naunang pares, still, sila pa din po yan. Next, yung baby rabbits na first batch na anak nung isang pares natin is tumanda or naging adult. And yung first pair natin ng rabbit ay nanganak uli. Ito naman yung second batch ng babies nila. So, for the third month, meron tayong isa, dalawa, tatlo. So, we have number of pairs as 3. Now, magpapatuloy yan. Magpapatuloy lang yung behavior ng growth ng breeds ng rabbits as long as walang namamatay sa kanila. Okay? Halimbawa, for the 4th month, yung first pair natin, which is ito, sila pa din po yan. Saan na ba sila? Nawawala sila. Yan. Okay. Yan sila. Okay. Then, yung first pair ng rabbit or yung first set na meron tayo ng mga babies, still, sila pa rin po yung adults na yun. And, yung second batch nung pares, nung anak nung unang pair natin, ay tumanda. Ngayon, since eto lang ang adults sa third month natin, sila lang po yung possible na mga anak. So, eto, meron siyang another baby rabbit. Then, ito naman ay nag-produce ng kanilang pares ng rabbit. Okay. Ngayon, meron tayong isa, dalawa, tatlo, apat, 5 pairs. Now, kung mapapansin natin, yung number of pairs after certain months ay nagpo-produce ng Fibonacci sequence or Fibonacci numbers. And yan ay totoo sa iba pang lahi ng mga hayop or insekto katulad ng bubuyog. No? So, yung paglago ng kanilang angkan ay may kinalaman din si Fibonacci sequence. Even sa mga puno na mayroon tayo sa ating garden or sa mga park, sa labas, no? Meron ding Fibonacci sequence na nakatago dito. Sunflowers. The number of spirals, either clockwise or counterclockwise, no? Meron silang Fibonacci number. On our illustration, on clockwise rotation, we have 21 spirals, which is a Fibonacci number. For the counterclockwise rotation, we have 34, still a Fibonacci number. How about the pineapples? The diagonal knobs, number of knobs diagonally sa ating pineapple ay may sinusundan ding Fibonacci number. 5, 8, 13. And even sa ating mga pine cones, katulad ng sunflowers, spirals ng pine cones ay may pattern ng Fibonacci. Sa ating mga bulaklak, okay? Callia lily, the number of petals, 1, Fibonacci number. Euphorbia, 2 petals, 2 Fibonacci number. Trillium, 3 petals, a Fibonacci number. Columbine, 5 petals, 5 is also a Fibonacci number. Black-eyed Susan, 13 petals, 13 Fibonacci number as well. And Daisy, 34 to 55 petals, and those numbers are considered as Fibonacci numbers.